Electrical nonmetallic tubing, commonly referred to as ENT, is a flexible, corrugated raceway used for protecting electrical conductors. It's often chosen for its ease of installation, particularly in residential settings. However, the National Electrical Code, or NEC, places restrictions on where ENT can be used, especially when it's exposed. In the context of a 3-story residential property where the first floor is partially underground and serves as a basement or garage, the question arises whether ENT can be exposed. The answer is no. Several factors contribute to this restriction. Firstly, ENT physical protection is a key consideration. In locations like basements and garages, wiring systems are more susceptible to physical damage. This damage can come from impacts, abrasion, or other mechanical stresses. ENT, while flexible, is not as robust as rigid metal conduit or intermediate metal conduit (INC). These metallic conduits offer significantly greater protection against physical damage. Secondly, NEC Section 362.12 outlines the permitted uses of ENT. While it allows ENT to be installed in concealed locations within walls, floors, and ceilings, it generally prohibits its use where subject to physical damage. Basements and garages, due to their inherent nature, are considered locations where physical damage is likely. Thirdly, consider the specific environment of a basement or garage. These areas often experience higher levels of moisture, humidity, and potential chemical exposure from vehicles or stored materials. ENT resistance to these environmental factors is less than that of metallic conduit options. While ENT is non-metallic and therefore resistant to corrosion, physical damage can compromise its integrity, leading to potential electrical hazards. Fourthly, the NEC prioritizes safety. The code aims to minimize the risk of electrical shock, fire, and other hazards. Allowing exposed ENT in areas prone to physical damage increases the likelihood of these hazards. Damaged ENT can expose conductors, creating a shock hazard. It can also compromise the insulation of the conductors, potentially leading to short circuits and fires. Fifthly, alternative wiring methods are available for these locations. For exposed wiring in basements and garages, options like rigid metal conduit, INC, electrical metallic tubing, ENT, or cable assemblies like Type MC cable offer superior protection. These wiring methods are designed to withstand physical damage and provide a more robust and safer electrical installation. Sixthly, local amendments to the NEC should be considered. Some jurisdictions may have additional restrictions or requirements regarding the use of ENT in specific locations. It is essential to consult local building codes and regulations to ensure compliance. Seventhly, proper installation practices are crucial. Even if ENT were permitted to be exposed in a specific location, its installation must adhere to NEC guidelines. This includes proper support, secure connections, and protection from physical damage. However, since it is not permitted to be exposed in a basement/garage, this is not applicable. Eighthly, consider the long-term reliability of the electrical system. Using wiring methods that are appropriate for the environment ensures a more durable and reliable installation. Exposed ENT in a basement or garage is more likely to be damaged over time, leading to costly repairs and potential safety hazards. Ninthly, the NEC aims to provide a standardized approach to electrical installations. This standardization promotes safety and consistency across different jurisdictions. Adhering to the NEC restrictions on ENT use helps maintain this standardization. Tenthly, when determining the appropriate wiring method, consider the specific use of the basement or garage. If the area is used for storage, workshops, or other activities that increase the risk of physical damage, a more robust wiring method is essential. 11thly, the decision to prohibit exposed ENT in basements and garages is based on years of experience and data regarding electrical failures. This data has shown that ENT is more vulnerable to damage in these locations, leading to a higher risk of electrical hazards. 12thly, the NEC is updated regularly to reflect changes in technology and best practices. These updates often include revisions to the rules regarding ENT use. Staying current with the latest edition of the NEC is essential for ensuring compliance and safety. 13th, the prohibition of exposed ENT in basements and garages aligns with the NEC overall goal of providing a safe and reliable electrical system for residential properties. 14th, consider the potential liability associated with improper electrical installations. If exposed ENT in a basement or garage is damaged and causes injury or property damage, the homeowner or installer could be held liable. 15th, it's important to remember that the NEC is a minimum standard. Electrical professionals may choose to exceed the NEC requirements by using more robust wiring methods in certain situations. 16th, when in doubt, it is always best to consult with a qualified electrical inspector or engineer. These professionals can provide expert guidance on the appropriate wiring methods for specific applications. 17th, the choice of wiring method should also consider the aesthetic appearance of the installation. While ENT can be concealed within walls and ceilings, exposed ENT may not be visually appealing in a finished basement or garage. 18th, the cost of different wiring methods should be considered, but safety should always be the primary concern. While ENT may be less expensive than some metallic conduit options, the added protection provided by metallic conduit is worth the investment in locations prone to physical damage. 19th, the NEC provides detailed requirements for supporting and securing wiring systems. These requirements are designed to prevent the wiring from becoming loose or damaged. 20th, the use of appropriate fittings and connectors is essential for ensuring a safe and reliable electrical installation. These fittings must be listed for use with the specific type of wiring method being used. 21st, the NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that the wiring must be installed in a way that is both safe and aesthetically pleasing. 22nd, the NEC includes requirements for grounding and bonding electrical systems. These requirements are designed to prevent electrical shock and fire hazards. 23rd, the NEC provides specific requirements for wiring in damp and wet locations. These requirements are designed to protect the wiring from moisture damage. 24th, the NEC requires that all electrical equipment be properly labeled. This labeling provides important information about the equipment, such as its voltage and current ratings. 25th, the NEC includes requirements for overcurrent protection. These requirements are designed to protect the wiring from damage caused by overloads and short circuits. 26th, the NEC requires that all electrical work be inspected by a qualified electrical inspector. This inspection helps to ensure that the work is performed in accordance with the NEC and other applicable codes. 27th, it is important to obtain the necessary permits before starting any electrical work. These permits help to ensure that the work is performed safely and in accordance with local regulations. 28th, the NEC is a complex and comprehensive document. It is essential to have a thorough understanding of the NEC before performing any electrical work. 29th, the NEC is not a substitute for good judgment. Electrical professionals must use their knowledge and experience to make sound decisions about the appropriate wiring methods and installation practices. 30th, the NEC is constantly evolving. It is important to stay up to date on the latest changes to the NEC. Therefore, exposed ENT is not allowed in residential basements and garages.